On the early morning of August 22nd, around 3 a.m., workers were busy with the steel strand tensioning operations on the key section of the Qinghai-Tibet Railway, preparing for the final connection of the Jianzha Yellow River Superbridge. The site was brightly lit. Suddenly, a loud crash shattered the quiet night as several crucial steel strands snapped, causing the bridge to lose its tension. In just 3 seconds, the 108-meter steel beam collapsed, and parts of the structure plunged into the fast-moving Yellow River below. Surveillance footage captured this dramatic moment. Construction equipment, including cranes, fell into the river, and several workers fell from different heights on the platform. At the time of the incident, there were 15 workers and 1 project manager on site. By 6 p.m. on August 22nd, the accident had resulted in 12 deaths and 4 missing persons. At least 1 person is confirmed to still be trapped on the unstable steel frame with unknown vital signs. 3 others who fell into the water have disappeared. The Jianzha Yellow River Superbridge has an arch about 100 meters above the water. Experts suggest that the survival rate after such a fall is very low. Online discussions have been buzzing with concern. Some questioned, how much force would it take for the steel strands to break like that? Was the anchor bolt not properly installed? Others worried about the safety risks once the bridge is finished, asking, what if something happens again after final construction? Rescue teams are working tirelessly to search and handle the emergency. Drones, helicopters, and rescue boats are still scouring the bridge and surrounding waters. Local residents heard a massive sound when the accident occurred. One resident recalled waking up at around 3 a.m., initially thinking it was an earthquake, only to later learn it was a construction accident. Videos from the scene showed one side of the bridge's steel frame still with cranes and other equipment, while the other side was missing a section, with broken ropes scattered around. According to another resident, the bridge was nearly complete before the accident. The right side rope suddenly snapped, causing green steel pipes to scatter, though the bridge structure was still intact at that point. The Jianzha Superbridge, located in Yachutun village downstream of the Yellow River in Jianzha County, Qinghai Province, spans nearly 1,600 meters. It consists of 3 consecutive steel truss arch sections. The bridge connects Jianzha County and Hualong Hui Autonomous County in Haidong City, crossing the Yellow River. Once finished, will be the world's longest-span double-track railway continuous steel truss arch bridge and China's first railway steel truss arch bridge over the Yellow River. This bridge is a key project of Qinghai Railway, constructed by China Railway Bridge Bureau's No. 7 project, under the 11th section of the Sichuan Qinghai Railway project. Public information indicates that for large-span continuous steel truss arch bridges, the biggest middle span typically uses a crane on the arch plus tension tower cantilever construction method. After the tower is built, a balanced beam with counterweight system is used for the side spans. The steel truss arch is joined using methods like edge support lifting beams, side longitudinal shifting, and cable adjustment to complete the connection. On June 14th, the tension tower on both sides of the bridge, reaching heights of over 100 meters, was completed. The construction company originally planned to invite media to the connection ceremony on August 26. The deputy chief engineer of China Railway Bridge Bureau's Xicheng Railway project, Jing Chengjing, stated in an media interview that the future construction will balance the immense forces generated during the cantilevering process by using the 1,000-ton pull of the steel cables on both sides. The maximum force on the side spans reached 1,161 tons, equivalent to the weight of 750 small cars. The single tower weighs 1,800 tons, and the large segment weighs 45 tons. The precision of the installation is crucial for the safety and success of the subsequent steel beam assembly. On the afternoon of August 22nd, a bridge-building machinery operator who had been involved in the project for nearly 3 years told reporters that the bridge had entered a critical phase for the bridge's main connection. He said on the night of the accident, the construction team was adjusting the cables. They weren't assembling the bridge, they were waiting for the cable adjustments to be finished before proceeding with the final connection. Another construction worker explained that the accident occurred around 3 a.m. during cable work. At that time, workers were adjusting the steel cables using jacks at the top of the Q tower, which is the main tower's identifier. The operator further mentioned that the accident took place near the side of Hualong County. with some impact on the opposite bank, but the damage was minimal. He noted that the bridge construction team and the cable installation team often worked together, and the workers who faced danger in the accident were well known to each other. Most of them were from Hubei, with some from Guizhou and Henan, aged between 30 and 50. As for the direct cause of the accident, on-site workers explained that the steel cables lost support due to the rupture of the anchor beam. The anchor beam is a key structural component used to secure the cables in suspension bridges. Workers on site observed that the 4 anchor beams broke into 8 pieces. They said the lifeline of the bridge lies in the anchor beams. Once the first one breaks, the others follow, like a domino effect. Just like in a cable-stayed bridge, when the anchor beam breaks, the steel cables lose tension, causing the bridge to collapse. On August 22nd, a technical director from the bridge construction unit explained that the bridge involved is a steel truss arch bridge. Before the bridge was connected, the steel structure at both ends of the Yellow River was fixed using cables made from steel strands. Before the final connection of the bridge, the main force was carried by the steel cables. Why did the steel cables break? He mentioned several possible reasons. One is that the lower cables may have loosened, and another is that the upper cables were under too much strain. However, based on the video, the breakage did not occur at the ends, so the accident is more likely due to the latter. He believed the cause of the rupture was complex and could involve factors like the quality of the cables, anchoring conditions, and construction loads, and further investigation would be needed for a detailed analysis. Another expert, who had long worked in construction safety, stated that if steel cables broke as reported, there are 2 major possibilities. First, the cables may have been used for too long, leading to corrosion and potential quality issues. Second, the cable ends might have been improperly tied, leading to slippage and rupture. However, the specific cause still needs investigation. An industry expert also suggested that the steel cables themselves might have quality problems. Surveillance footage shows that the steel cables suddenly snapped during the tensioning process, causing sparks to fly and scattering broken steel cables at the scene. The Jianzha Yellow River Super Bridge began construction in 2021, and it has now been under construction for nearly 4 years. Steel strands, which are a core component of the bridge's cable-stayed or suspension cables, typically have a specified design lifespan. According to relevant standards, the design life of steel strands is usually 5 to 10 years, with regulations requiring regular testing of these cables in harsh environments. It is speculated that some of the steel cables might have been installed or procured during the early stages of construction, around 2021, and they may have been exceeding or approaching the 4-year storage or usage cycle. The harsh, high-altitude environment in Qinghai could accelerate aging. Additionally, during procurement, the winning bidder is often selected through a tender process, which sometimes involves political connections, with suppliers providing substandard materials for profit. Even without corruption, the quality of products manufactured in China can vary. In a video analysis by Douyin blogger Engineer Li, he suggests several possible causes for the collapse.
看视频垮到的那一瞬间，我觉得可能有以下原因。
During the final connection, there might have been an elevation discrepancy on both sides, leading to an adjustment on the front cables. This adjustment could have been uncontrolled, with possible violations of procedures. After installation, the front steel cables were either not properly tensioned or were delayed in being tensioned. This could have led to instability in the lower anchor points, or the lower section not being welded or securely connected during unloading. Uneven tension during the steel cable's tensioning process could have caused an imbalance in the force on each cable. If some cables were overstressed, this would have led to the destabilization of the entire set of cables. The design of the plan could have been faulty, or there may have been violations of operating procedures or overloading at the site.
An expert on Zhihu analyzed footage of the construction site and pointed out that during the preparation for the final connection, some of the steel cables were visibly slack and not tensioned properly. This left them in a non-stressed state, which caused the load on certain sections of the cable to exceed the limit, making them prone to breaking. While 6 cables were designed to bear the load, only 4 were actually under tension. When these 4 cables snapped due to overloading, the 2 slack cables could not take over, triggering the accident. A commenter on Zhihu noted, "This isn't very professional. Not tensioning the steel cables in time is definitely a violation of regulations." A civil engineer on Zhihu also discussed the issue, stating that the steel cables likely broke due to quality problems. The problem could be related to the quality of the steel cables, the anchoring equipment, or the anchor box. He also mentioned that there could be issues with the calculation or control systems, although he believed that this was unlikely, as such projects typically have control calculations managed by bridge institutes, and errors in these instructions are rare. It indicates that the quality control throughout the process had been compromised. Some netizens have speculated the possible causes of the accident. 1. Uneven tensioning of the steel cables during repeated adjustments. 2. Weakening of the cable clamp positioning due to repeated adjustments. 3. The anchor beam welds may have detached. Of course, until the official accident report is released, all of this remains speculation. Following the accident, many media outlets questioned why such a major project was being constructed at night. Was there a rush to meet deadlines? In response, Mr. Zhou, a road and bridge engineer, explained that steel structures, especially bridges, are highly sensitive to temperature changes due to thermal expansion and contraction. For large bridges, controlling the alignment is critical, and nighttime construction ensures that temperature variations are minimal. This makes the bridge less affected by temperature changes, making measurements and construction more stable. For crucial steps like the final connection of the bridge, construction is typically scheduled at night for better stability. The Qinghai Provincial Emergency Management Department also stated that nighttime construction was chosen to prevent changes in the properties of the steel cable, with cooler nighttime temperatures helping maintain stable rod performance. As for the question of rushing the project, on-site workers' descriptions indicate that there was indeed a sense of urgency. According to media reports, the bridge was originally planned to be connected in July, but due to various reasons, it was delayed by a month. The construction had already fallen behind schedule. On-site workers mentioned, to ensure the final connection of the main bridge by the end of August, we've been working overtime every night. Working late has become the norm. According to the Qinghai-based Xihai Metropolitan News, in June 2025, more than 100 workers were using a black and white schedule, working in 2 shifts around the clock to accelerate the process. Therefore, while the 3 a.m. construction time was chosen due to favorable temperatures, the pressure to catch up on the schedule was undoubtedly a major factor. In China, large-scale projects are often closely linked to politics. To showcase the so-called achievements under the Chinese Communist Party and to reinforce the party's legitimacy, leaders of state-owned enterprises often use major projects as gifts to please high-ranking CCP officials, gaining political capital for career advancement. The Jianzha Super Bridge, with a total investment exceeding 2 billion yuan, is promoted as China's first railway steel truss arch bridge over the Yellow River, and the world's largest span double-track continuous steel truss arch bridge. It is being presented as a key national project. The accident occurred just before the 80th anniversary of the victory of the war against Japan and CCP's National Day, a prime time for such engineering gifts. Currently, infighting within the CCP has intensified, with party leader Xi Jinping planning a grand military parade for September 3rd. At the same time, he's responding to widespread rumors of him losing power. Under Xi's leadership, China's economy is teetering on the brink of collapse, and he desperately wants some good news. Major safety and quality accidents triggered by rushed engineering gifts are unfortunately not uncommon. For example, the July 23, 2011 high-speed train collision, which resulted in 40 deaths and 192 injuries. That incident was closely related to such pressures. The collision occurred because of a signal equipment failure, but the deeper cause was the rush to complete the high-speed rail system, which led to inadequate design and testing. The Yongwen high-speed railway, which opened in September 2009, was pushed to launch just before the 60th anniversary of the founding of the People's Republic of China. Official media and the Railway Department repeatedly promoted the project as a National Day gift, aimed at showcasing China's high-speed rail technology and economic progress. The China Railway Corporation even referred to it as a grand gift for the 60th anniversary. On November 24, 2016, during the Phase 3 expansion project of the Fengcheng Power Plant in Jiangxi, the construction platform of Cooling Tower No. 7, which is about 70 meters high, collapsed. It resulted in 73 deaths, 2 injuries, and direct economic losses of 102 million yuan. Local governments aiming to showcase economic achievements ahead of the 19th CCP National Congress demanded an early completion. After winning the bid, the contractor compressed the timeline from 110 days to 70 days. They poured concrete continuously at night and ignored construction regulations, leading to the tragic collapse. According to data from the China Construction Industry Association, safety accidents due to rushed construction deadlines accounted for about 25% of all construction accidents from 2010 to 2020. The construction cycle of the Jianzha super bridge was artificially compressed, with design plans adjusted multiple times. The construction team was instructed to maintain both speed and quality. As a result, the project site was chaotic, with construction procedures frequently compressed and safety redundancies reduced. In the context of the CCP's major projects, the project was never treated as a guarantee of public safety, but as a political showpiece and a symbol of national power. If the so-called gift engineering impulse is not curbed systematically, such tragedies will continue to occur. Henry Lee, a current affairs commentator with years of engineering management experience in China, explained that large-scale projects often face severe management issues, with subcontracting being the most prominent problem. While the Jianzha Super Bridge was officially contracted to the state-owned China Railway Bridge Bureau, many sub-projects were contracted out to various construction and supply firms. State-owned enterprises typically don't have enough workers, so they often rely on subcontractors to handle the specific construction work. Subcontractors, in turn, divide the tasks further, often to second-tier subcontractors. Large projects often see 4 to 5 levels of subcontracting. In the end, the workers are mainly untrained migrant laborers. In this structure, each level of subcontractor takes a cut, leading to a significant reduction in the final construction funds. The procurement process is especially corrupt. Key materials, such as steel and steel cables, are often not procured through transparent bidding, but are controlled by insiders who secure low-cost bids and then sell them at inflated prices, often leading to substandard materials being used. The steel cables that eventually reach the site may be far removed from the original technical requirements. This construction model completely undermines basic safety principles, but it is all too common within the CCP's engineering system, leading to frequent safety accidents and widespread construction problems. What's even more serious is that the project management usually only appears during the signing and acceptance phases, with daily supervision practically non-existent. The supervision unit, design institutes, and contractors form a community of interests, silently colluding and turning a blind eye. As long as the project can be completed on schedule, quality issues and safety risks are hidden away. This false compliance management is a microcosm of the corruption in engineering under the CCP system. Engineering accidents are not really accidents, they're systemic inevitability. As a leading state-owned infrastructure company under the supervision of the state, China Railway Group has repeatedly been criticized for quality issues, with doubts raised about systemic management defects. Therefore, this accident is not only a tragedy of engineering quality, but also a mirror reflecting the deep-rooted issues in CCP-led infrastructure projects. The short-sighted pursuit of political achievements, the corruption chain of subcontracting, chaotic management, and the lack of accountability. Ultimately, these problems are rooted in the CCP's highly centralized and unmonitored political system.